Hello everybody, my name is Stefan Nieuwenhuis. I'm a developer advocate and software engineer at the largest online retail retail company in the Netherlands and Belgium, bol.com. Besides that, I have a master's degree in archaeology. I just graduated here at the University of Amsterdam, so it's really cool to give a talk here in Amsterdam as well. I'm a water polo player, I love to read books, and I occasionally jump out of planes, but with a parachute that is. And today, I'm going to tell you all about our amazing adventure we're currently having with Micro Frontends design systems that are built with Angular and StencilJs. So let me first start off right away with telling you something about how the company is organized. At Bol, we strive to provide our customers with the best user shopping experience they ever had. We do this with about 1,500 people, and 500 of them are in IT. And they're organized in about 70 autonomous development teams. And I explicitly call them autonomous because each team has their own unique way of working and is completely free to pick whatever tech stack they feel most comfortable with. Our experience is that this rate of autonomy is really enhancing the production speed, creativity, agility of teams. But with great freedom comes great responsibility as well, because every team has complete access to the production environment and is completely free to deploy at will. So that means that they really have to take ownership about their processes they're managing. And at bol.com we're telling every team that we have a mantra, and the mantra is you build it, you run it, you love it. So you have to take responsibility of the things you build, and if you don't love it anymore, you have to be able or to rebuild it in such a way that you're going to love it again. Every team is organized in a so-called fleet, and a fleet is basically a group of 3 to 5 teams that has a shared business goal. For example, we have a fleet that focuses on pricing and one on logistics. And every fleet, every group of 3 to 5 fleets is grouped in a so-called space. And a space is basically a group of fleets that has a larger common business goal. For example, we have a marketing fleet and a pricing space. Since 2013, we basically had to split up the company into two. Why? Because since then, we opened up our platform to external sellers and welcomed them to add their assortment and sell their assortment via our web shop. So until that moment, we really focused on ourselves. And so we basically focused on the web shop part of the company. But now we had to provide all the services we built for ourselves to the sellers as well. And the remainder of this talk will be focused on the tooling we've built for those sellers, hence retail tooling. And how does our architecture match with this organizational structure? Well, as befits a true archaeologist, let me start by telling you a small history lesson about our architecture. Back in 2013, we basically had 2 huge monoliths. One for the web shop and one for the sellers. And we weren't very happy about that. And why? Well, let me explain you about that with the following scenario of the seller that wants to add products to the catalog via that huge seller's monolith. The seller, it's adding products to the catalog. The front end of the monolith pings the back end. And basically queues the backend to process the request. Well, the backend starts a request and processing until it's finished, and then it pings the front end again, and the front end notifies the seller. Well, at first, this seems like a pretty solid solution, a pretty viable and firm solution to add products to a catalog, but it's not scalable at all. Because just imagine this scenario is only about one seller, but just imagine 1,000 sellers want to add their assortment simultaneously. Well, of course, we can scale up both front and back-end capacity, but that's not a scalable solution at all. because the backend contains separation of concerns. You have to imagine that a monolith is basically packed with all kinds of processes. One for uploading products, for example, one for analyzing the uploaded products, and one for displaying or processing those products. So if we really want to scale up, we have to separate all those concerns and scale them up separately. And besides that, the user experience a seller has is not very nice as well, because the seller has to wait all the time for the process to be finished. It's like being at a fast food restaurant, trying to order a meal, and you have to wait at the teller in order to be served. And in the meantime, you're keeping up the queue after you as well. So it's not very convenient, scalable, user-friendly as well. And just imagine the front end. It's basically one huge application maintained by different autonomous, or supposed to be autonomous, development teams. And, well, there's nothing much autonomous about those teams here, because everyone has to agree on one unique way of working, and has to agree on one tech stack. But in meanwhile, teams really want to be autonomous, and as I told you before, with lots of autonomy, they thrive. They perform at their max, and this way they can't perform at their max. So, how do we solve those problems? Well, enter microservices. With microservices, we have a completely different approach about the problem. We basically analyze all the processes, the business components in the huge monolith, and we're trying to separate all of them in so-called little containable services, hence microservices. As you can see here, for example, we have a microservice for uploading products. We have a microservice for analyzing data. Same goes for processing data. And we did the same for the front end as well. So this setup is much more scalable, because if we need to cover another business process, we can basically create another microservice in order to serve that process. And the same goes for the front end as well. And besides that, we can massively, dramatically improve the user experience for a seller as well. Because remember the same scenario in the monolith, the user had to wait, and basically the seller wants to be able to get notified along the way. He wants to get notifications and basically wants to be in control. Instead of that, the system is in control. So with the new microservices setup, this is actually possible. We still have the same scenario of a seller that wants to add products to the catalog, and he immediately receives a confirmation, and then he's completely free to listen for announcements of the system. And it's completely free as well to take any action whatever he likes. Very scalable. And here, this is the result of splitting up the front ends into different services as well. Remember that slide of that one huge planet, one huge front-end application? Well, we've now split them up in 4, and every team can really thrive, because every team can take ownership of their own service, and can pick whatever tech stack they like, and can implement their own way of working. So with this, with microservices, the company can really thrive. All right, to summarize, what are the pros and cons of a microservices architecture like this? Well, first of all, it's scalable. Besides that, teams have a lot of independencies. As you might can recall, if every team is working on the same application, there are lots of dependencies between all those teams. They basically have to operate like one big team. And in a microservices architecture, you don't have to do that anymore. You still have dependencies, of course, but way less than in a monolith architecture. Then decentralized governance. In a monolith, it's quite impossible to split up governance between all the services that are packed in that monolith. And with a microservices architecture, it becomes a possibility because every service is basically on its own. Then, the same goes basically for testability. The testability of a microservice is pretty straightforward because it contains only one tiny piece of functionality of the complete chain. So that is way better to test than test the complete chain at once. Well, same goes for this. Keep it simple, stupid. And last but not least, there's no single point of failure anymore. But then there are downsides as well, because microservices landscape can grow enormously and can become quite complex. So monitoring can be quite a hassle, quite a challenge, especially in comparison with with Monolith, because there you can basically monitor one huge machine. Well, same goes for complexity. Every microservice can potentially connect to another microservice, which can become quite entangled. The landscape can become quite entangled. So hence complexity. And then we have the corporate culture, because having a microservice architecture requires lots of freedom and lots of trust for the development teams. So your company has to be ready for that in order to implement such a system. And last but not least, consistency, because the independent and decentralized nature of an architecture and the autonomous nature of the development teams can cause or jeopardize the consistency of a supposed to be uniform retail tooling platform. And let me elaborate on that a little bit more with a small history lesson. Let me take you back to the 1950s, to the start of the Cold War and the start of the space race, and the start of the first ideas of a reusable spacecraft by the Soviets. But as all those ideas come and go, and basically the Soviets lost interest a bit in the idea, and basically the idea of a reusable spacecraft faded away. But that changed all in the 1970s with the start of NASA's space shuttle program. The perceived military threat really worried the Soviets because the space shuttle had a huge payload, and they thought they were able to bring up lasers into space which were able to destroy enemy's missiles, for example. And they were also a bit concerned that the space shuttle could dive out of space and drop bombs onto Moscow. So they have to handle fast. And they handled fast in the form of the Buran reusable spacecraft. And as you can see on the picture, they look quite similar, and that's no coincidence, because at first the Soviet engineers were a bit reluctant to take the design of, or get inspired by the design of the arch nemesis, but wind tunnel tests proved them that it was actually quite a perfect design, and it was foolish for them to design a completely new spacecraft that is probably inferior. So the next step they took was to take, a lot of information about the space shuttle program and start building it. They started building it in 1980 and they finished it in 1984. And although the Soviet engineers got really inspired and, basically used some of the components, they were basically reinventing a square wheel over and over and over again. And you might wonder, where does he want to go with the story? Well, basically, and it might seem a bit far-fetched to you all, this happens every day, at least at ball.com. Engineers reinventing a square wheel over and over again. And if I only got a nickel for each time that would happen, I would be rich by now. And I think it has something to do with the autonomous nature of the development teams and the independent structure of our landscape. So what we have to do is get all the teams basically on the same page again and enable them to speak the same language in order to contain consistency in our retail tooling platform. So how do we do that? And funny enough, I asked the teams what they need for that, and they came up with quite a consistent answer. They basically need a design system that's framework independent, because every team is completely free to pick whatever tech stack the team is comfortable with. Most of them go for Angular, some tend to stick to Angular.js, some even go for React, or tend to stick to vanilla.js, for example. So it's very important to them that a design system is framework independent. Then it needs to contain one single source of truth, because you might have experience with that as well. There are pieces of information, walkthroughs, tutorials, scattered around the complete company, and so and that's quite inconvenient. And yeah, most of the information gets lost, which results in reinventing a square wheel over and over again. So one single source of truth is key for success. Then, besides that, the teams really want to be able to contribute. They want to the design system needs to be a community-driven project. Then it needs to, all the components in the design system needs to be integrated flawlessly to the current applications and the future applications. And yeah, I told you already, they really want to stop reinventing a square wheel over and over again. And that's very good news for the consistency of our for our platform, but not so good for my nickel collection and my plans to get rich by them. And they have to keep their freedom as well, due to the autonomous nature of all the development teams. And it needs to be as easy as possible to implement it, and it needs to be as easy as possible to contribute to it as well. And last but not least, it needs to be performant and scalable too. All right, so what's a design system? Well, a design system is basically a collection of reusable components guided with clear standards where you can build any number of applications with. It consists of a style guide, and you can see it, a style guide as the core of a design system, and it basically contains the visual identity, the brand's identity. So in our case, it contains the identity of a retail tooling platform, and which contains, for example, description of all colors being used, the typography, you name it, sizing, spacings, imagery. Next to that, we have the components library, and the components library is basically the big box of reusable components. And last but not least, we have the pattern library, which describes how to use and why and when to use a certain component. So to summarize, what are the pros and cons of a design system? Well, first of all, it can really enable teams to build a consistent user interface. Components are reusable, so we don't have to reinvent the square wheel over and over again. The maintenance is easier, because just imagine every team is building the same button. So every team has countless variants of buttons being built in comparison with only one button that lives in the components library. So you only have to do maintenance in a components library instead of all applications. Then it contains a single source of truth in the form of a pattern library and a style guide. It's very scalable and flexible as well, because just imagine if we want to do a complete design overhaul of our retail tooling platform. If we don't have a design system, we have to upgrade every component in every application at once, and yeah, that's quite a tough job, very lame job as well. And if we have a design system in place, a components library in place, we only have to upgrade the components in that design system, and users the developers that have those components included in their application as dependencies just can upgrade the version number. And of course, it really increases development speed. But what are the cons? Well, a design system can really come with some constraints, because a design system basically, well, tells people what and how to build an application. Besides that, the convergence bias. Yeah, well, it's basically a tunnel vision that developers can create, because a design system contains so many rules and is quite opinionated that developers can create or develop a tunnel vision. So you have to be very careful to prevent this. And then the tendency to inflexibility, and that's basically coherent with the convergence bias, because the design system with its rules and with all the components there, basically forces is not the right word, but forces developers to go in a certain direction of consistency. So, how is our design system being used? Well, here you see a small picture of our landscape. In the middle, you see our design system with all the components in place. Well, we have some documentation there as well. And around them, they're floating all the front-end applications. All the micro frontends are floating around them. And if the teams want to use components, well, they basically can get it out of our system. Our design system is stored in a so-called artifactory. All the dependencies are stored in a so-called artifactory. And each development team has access to that artifactory and is able in that way to use all the components. But what if they want to contribute to it as well? Well, that's possible as well, because inside the company, we made the design system open source. Like I told you before, we really want to enable the community of developers to contribute to that design system. We really want to enable them and to be free and to be contributing. So that's very possible as well. And then I talked about reusability, flexibility, but not about the framework independency that was one of the requirements of the developers. So that was a quest that we need to finish before we definitely could implement the design system. Because every team basically has their own technology stack, it was very important to find, to not lock ourselves into a certain framework like Angular, for example, or React, or you name it. So we finally found a solution in the form of web components. And web components provide us with huge flexibility because they're natively, well, say it with polyfills, supported by all the modern browsers out there. We don't have to worry about framework lock-in anymore because, they're natively supported and we don't need the framework to build them. They're reusable and generic as well, so that makes us quite flexible. But there's a huge downside to web components as well, and that's the learning curve. To create and to build a web component from scratch, there is a very steep learning curve into that. It's quite hard to do so, and we want to make contributing to our design system as easy as possible. So implementing vanilla web components was out of the question, and our quest continues. And then we stumbled upon StencilJs. And StencilJs is basically a web components compiler, which uses the web standards in order to generate web components. And besides all the pros we had with that come with web components, Stencil is really performant because it's only a few. The library itself is only a few kilobytes big. It's a very easy API. It's quite similar to Angular. It's future-proof, hence web components. And it's supported by all the major frameworks out there, and you can even use it with vanilla.js as well. So, we finally made a decision about which frameworks, which tools we were going to use, and we ended up with StencilJs. But how do we make the design system a great success inside our company? Well, by enabling the community. And how do we do that? Well, we realized that we really need a core team to provide the basic support to the development community. But the core team doesn't need, we need to prevent that the core team becomes an ivory tower, so to say. Because if a core team gets detached from the development community, the design system cannot become a success because it needs to be carried by the community. And we have to share knowledge with each other. Due to the independent nature of both teams, development teams, the development community, and microservices, the incentives for inter-team communication are a bit lower than compared to a monolith architecture. So really need to get all the teams together and share knowledge. Well, same goes for education as well, because web components, it's still quite new, and StencilJs is, although it's very convenient, it has an easy API, it's quite new to our developers community as well. So we have to share knowledge and educate everyone about that as well. Then we need to provide support, obviously, and we have to maintain the design system as well, because a good, straightforward documentation is key to the success of a design system. And last but not least, we have to innovate, because now we're all making use of Angular and other kinds of front-end frameworks, and web components are a great solution for a design system, for components library in the design system, but is it really the future? We'll have to keep our eyes open, and we have to keep innovating ourselves and reinventing ourselves as well. So what have we learned from this? Well, we definitely need a core team to guide the rest of the community. We have to keep collaborating with each other. We have to spread the word, because what's the use of a design system if no one knows about it? We have to spread the word throughout the company that it's available and that it can be used, and basically that it must be used as well. We have to make it as easy as possible, and everyone needs to be able to adopt it. So what are our future plans? Well, currently our design system is in-house company product, but we really want to investigate how we can bring this to the open source community outside the company as well. So in the upcoming period this year, we will try to bring at least parts of our design system outside of the company and bring it to the open source community. So that's really exciting, and meanwhile, we're going to improve our systems and our way of working as well. So my name is Stefan Nieuwenhuis, and I hope you enjoyed my talk about microservices, micro frontends, design systems, and StencilJs. And are there any questions?
Questions, where are they? Are they hiding?
Maybe you need to turn the light on.
Oh yeah, can we turn the lights on perhaps? Yeah, oh yes, I see one right in the back. It's a big run for me.
Sorry for the noise.
No.
Oh wow. It's really at the last row.
Hello. Hey, first of all, thanks for the talk.
Welcome.
A question for you. Does bol.com have offices in different locations?
No, we currently have one office location based in Utrecht.
Yeah, because my company has like a lot of different locations. So if you want to like implement a design system across like multiple locations, different offices, different cultures, like what would be like best practices to implement those changes? Do you have any ideas?
Well, yeah, we're basically facing the same problem because we have a huge office building that consists out of 5 huge towers with 4 to 10 stories each. So, and every floor has its own culture, and it's very difficult to connect with each other because of the physical distance. So what we're basically doing is organizing knowledge sharing sessions between the community of developers, and that really helps to share knowledge and getting to know each other and basically connect to each other. So that can be an angle to take for your company as well.
All right, thanks so much.
Of course, you're welcome.
Any more? Any more? Where are they? Oh, at the front. Haha. It's like a game. Question to the technician from my colleague. Can you turn up the speakers in the middle? That would be wonderful. Thanks.
In the front.
You spoke about how it was hard to incentivize inter-team communication.
Sorry, I didn't hear.
How to incentivize inter-team communication?
Oh, that's a very good question.
Yeah, I wondered if you could expand more on that.
Okay, yeah, of course I can. Well, that's basically the biggest challenge we're currently facing because, due to the autonomous nature and the independent nature of our landscape and our teams, it's quite hard to get all the teams together and get them on the same page. So one way is organizing knowledge sharing sessions, and really the core team is really trying to connect people by visiting them as well. And another angle we're currently investigating is gamification, for example. So we really try to incentivize the teams to be able to contribute and to use our design system by gamification, basically.
Wonderful. Games. I like that. Yeah. Any last questions? It seems like there's not. Obviously, it's still quite hot in here. We are trying to balance out not drowning out the speaker with the noise with this main door, so we've opened that for now for the air conditioning and the airflow. The air conditioning is on full. We're going to see what we can do at lunchtime. But anyway, thank you, Stefan.
Thank you as well.